Okay, so what we're going to do now is take a look at how to work with a world space and a local space when we are dealing with constraints. So go ahead and click on this object and go to the Constraints tab and open this up. Now here you're going to see a bunch of constraints that we can use on this object. Now when we are building our rigging system, we're going to be using the copy location, copy rotation, copy scale, and copy transforms. Few additional constraints we will use, but we will look at them when we get to the actual rigging process. Now, some of these constraints cannot be used on objects, such as the inverse kinematics and spline IK. If you hover your mouse, you can see in the description that it says bounds only. And if you click it, you'll just get an error message. Now, when we are working with the actual armature, we're going to see the same exact menu. Okay, so over here, copy transforms simply means that it's going to package copy location, copy rotation, and copy scale into one constraint. So when we do copy location, we're simply talking about copying the location values of one object to this object. Same thing for rotation and scale. So go ahead and click on copy location. Now, the thing that I want to point out over here is that when we are dealing with parent-child relationships, here you can say that these objects are simply attached to each other. But when we are using such as the copy location constraint, we're simply just talking about numbers, values. So meaning that if we click on this object, we can copy the location values from it and inject them into this object. So this object, when it's using the copy location constraint, is not going to be related to this object in any way. It's just using its numbers. Now over here, if you hover your mouse, you'll see that it says the space that a target is evaluated in and the space that the owner is evaluated in. So this means that this is the target and this is the owner. Now, if we want to copy the location values from this object, we can simply click over here and select the object. Now, when we have a bunch of objects over here, it's easier to simply click on this eyedropper tool and hover our mouse over the object. Once it highlights, just click it. Or a better way to do this is you can simply click on the target object, press the shift key down and click on the owner. The reason we have to come back to the owner is because we have to come back to his properties. Now just do Shift Control C. Now just do copy location. You'll see that it's going to fill up that information. Go ahead and now turn off the constraints and go ahead and click on this object. So right now what we're doing is dealing with two objects that have no parents. So this object, just like this object, is showing how far they are from the center of the 3D grid. So when we go ahead and turn these off and turn on these constraints, when we say that we want to use the Z values from the target object, you'll notice that this object is going to move exactly where this object is on the Z axis. And of course, if you click on X, this object will go exactly to the same position as the target object. Now we're not using the Y value, so it's not going to matter, but just go ahead and click this. Now go ahead and invert the Z value. So here you can see that all this object did was take the Z values and invert that. So this is why it appears over here. Now if we invert the X values, then this object, of course, is now going to move on the X and it's going to appear over here. Okay? So go ahead and just turn these off. Now, over here, what I want you to do is first go ahead and turn this off. Notice that on this object, we can see how far it is away from the center of the 3D grid, just like this object. But when we enable this, you'll notice that the owner object is not going to show the values that it's getting from the target object. This is because you can turn off the constraint at any time, and this object needs to go back to where it was. So right now what I want you to do is press the S key to just scale this a bit. This is so it makes sense when this object actually overlaps exactly on this object. Now go ahead and turn this on, okay? Now, in order to use the numbers that are being displayed on our object, we have to use this offset button. So to understand how to use this, go ahead and turn this off and do Alt-G to reset its location. Click on this red arrow and move it to the right. So now go ahead and turn this back on. You'll notice that right now this object is simply going to overwrite, or really use the values that are coming from the target object. It's not going to use its own values, meaning how far it is or was away from the center of the 3D grid. Now when we click on offset, if you hover your mouse, you'll see that it's just going to add the original location into the copied location. So what this means is that first this object is going to use the values that it's getting from the target object, so it will appear exactly over here. Then it's going to add additional values from its own location on top of those values. So this is why it's pushing itself away. That's all this means. Now the other thing here is that when you have this off and when you press the G key and try to move this object, it's not going to let you because the constraint is stopping it from doing that. Right click to cancel. Now notice that when you press the G key, you're going to see these numbers move. And if you press the left mouse button, these numbers are going to stay here. So if you turn this off, you'll notice that the object has moved from its original position. So here I'm just going to do Alt-G to reset this and move it back over here again. Okay? Now in order for this to not happen, again, you have to treat it like bounds. You have to simply lock these. Now when we turn this on and press the G key, we cannot move this object, and nor are these numbers going to change. So just keep this in mind. So here I'm just going to keep everything unlocked over here. Now the other thing over here is that you can see that we can actually decide how much of the target location values do you want to use. So here we can, let's say, go close to, let's say, halfway. So now when we click on this object and press the G key, you'll notice that the owner object basically moves half the speed. So right click to cancel this. Go ahead and click this object and increase this. Now remember, both of these objects have no parents. So when we look at this over here, it's saying that the space that the target is evaluated in. So it's simply talking about the world space, right? The world coordinate system. So the local space is when your object has a parent, right? Meaning it's talking about objects like this. So this object would be using its local coordinate system. So go ahead and click on this object. So you can see that both objects, because they have no parents, are simply using world space. Now what this means is that here Blender is going to use the global coordinate system to evaluate the numbers that are being displayed over here, meaning how far this object is away from the center of the 3D grid. Because it's going to give the same values to this object appears exactly in the same location. Go ahead and now X this out. So now let's take a look at how does this work when we are dealing with objects that have parents. Now later on we're going to take a look at working with objects that have no parents, where you can actually click on a local space. But that's a little trickier to understand, so I'm going to explain that separately. So first go ahead and click on this eyedropper tool and go ahead and select this object. So you'll notice that this object is going to appear exactly where this object is. So let's understand what's going on over here. So here what we're saying that the target object should be evaluated in world space. What this simply means is that Blender is basically saying that this object does not have a parent. So it's going to find out how far this object is from the center of the 3D grid, meaning using the world coordinate system. Then it's going to give those values to this object, which is also operating in the same world space. So this is why this object appears exactly in the same location. Now, when we switch this to local space on the target object, now we're saying that we want the location values of this object as to how far it is away from its imaginary center. Go ahead and click this object. So you'll see that here Blender is giving those numbers and throwing them into world space. So this is why this object appears over here. Basically, it's the same distance from the center of the 3D grid because it's operating in world space. And this object is operating in local space. So if you click on this object and bring this object to its imaginary center, you'll see that the other object, it's also going to move to the center of the 3D grid. Okay, I'm going to right click to actually rotate this so we can move this object out of the way. Press the G key. Notice that how it moves, right? That's all that's going on. It's basically a conversion from local to world space. Now let's see what happens when we switch this to world space. Now again, here we're going to be evaluating where this object is from the center of the global coordinate system. Now over here we can't really choose a local space because this object has no parent, and if you click it, really it's not going to do anything. Okay, so you can see how that concept is working. Now one thing that I do want to show you over here, if we switch to local space, we can actually click on this object and press the S key and scale this down. See? So this object still is not going to budge because the numbers are always going to be kept intact, meaning that if we click on this object, you'll notice that the numbers are exactly the same. Where it will make a difference is that now when we switch to world space, you'll notice that now Blender is going to take a look at where this object is based on the world coordinate system, forget that it has a parent, and now going to give that information to this object, right? So meaning that if you use the world coordinate system, it's finding that the object here is below the X and Z, so this object appears in the same exact way. Okay, that's how that works. So go ahead and click this and do Alt S to reset the scale. Go ahead and click on this object and let's just remove the constraints. Press the G key and just move it over here. So now we're going to take a look at how does this concept work when we're dealing with objects that both are in a local space. So let's go ahead and click on this object, press the Shift key down, click on this one. Now do Shift Control C, and here we're just going to do copy location. Now again, right now we're evaluating both objects in world space. So simply Blender's taking a look at this object over here and finding where it is according to the world coordinate system and giving that information to this object, which also is being evaluated in world space using the world coordinate system. This is why this object simply appears where this object is. Okay, now here we're going to do the same thing. We're going to say evaluate in local space. So this object is showing how far it is away from its imaginary center. I've been giving that information to this object. And this object is being evaluated in world space, meaning using the global coordinate system. So it's going to position itself based on the center of the 3D grid. So if you click on this object and bring it to its imaginary center, press the G key, you'll notice that it does the same thing. It goes and brings this object to its center. Go ahead and press the G key and move it back. Now here, if we say local space, it's going to do the same thing, but do it in local. So over here, if we click it, press the G key, you'll notice that it's going to move according to how far this object is moving from its center, imaginary center. It's going to make this object do the same thing. I'm just going to press the R key to rotate this bit. Go ahead and zoom in, press the G key. Notice that how this behaves. So you can see that we can create very elaborate systems with use constraints, right? So you can see that how this first object reacts, this object, how it moves. Anyways, that's how this concept is working, right? So of course, if we do this in world space over here and keep this at a local, you'll notice that over here, this object is showing that it's on the left side of the Z and x-axis. So this object, what it's doing is basically using this Z and x-axis and putting it exactly on its side. Okay, so if we click on this object, press the G key and move it again to its center, you'll see that how this is working. See, it's on the left side over here on the global Z. I'm gonna just show this to you over here. This is the Z, and this is how far this object is away from it. Over here, this is the Z, and this is how far this object is away from it. Okay, so it's a pretty straightforward concept as to how it works. Now let's go ahead and now just reload this file. Now, in the same way, we can do the same thing with the copy rotation. So here we're going to click on this object, press the shift key down, click on this one, do shift control C, and now do copy rotation. So here again, we're just using world space. So here Blender is going to take a look at how is this object rotated based on the global coordinate system and give that information to this object, which is also operating in world space using the global coordinate system. So if you press the R key, you'll notice that both objects are going to rotate exactly the same. Now, if we click over here and say that, okay, evaluate yourself in local space and give that information back to world space, you'll notice that over here, if I just press the G key and move this and move this here, remember, we're not doing location, only rotation. So that's why we can move these objects. If we click over here and press the R key to align this object exactly with its Z local coordinate system, you'll notice that it's happening over here on this object. It's aligning itself with the global coordinate system Z and Z. And if we rotate this and align it with the X, that's exactly what it's going to do over here too. Okay, so that's how that is going to work. Now over here, let's do world space. Now again, we can't really do local because this has no parent, so clicking on it really is not going to do anything. So we're going to take a look at that concept later. Now of course, we can do the same thing with scale. So now go ahead and let's say click on this object, press the shift key down, click on this one, do shift control C, and now do copy scale. Now this again is using the world system. So if we click on this, press the S key, this object is going to scale based on how this object is scaling on the world coordinate system, right? Now if we click on this object and do a local space, you're really not going to see a change, but you will if you click on its parent and press the S key, right? Notice that how small this object is now. So when we click over here to world, you'll notice that it's going to scale exactly how Blender sees it being scaled in world. But when we do a local, right, it's going to scale back up, is because if you click it, you'll notice that it hasn't been scaled. And when you press the S key, it's basically coming from a smaller scale version and coming back over here. So it's just a translation. And of course you can do this world, and doing local is not going to do anything because this object has no parent. So anyways, that's how these concepts work. So let's go ahead and now reload the file, and I'll see you in the next lesson. Thank you.